Okay, so let's discuss a question from thermodynamics. Basically, it's from IC engine. We need to find out the standard efficiency of diesel cycle. So first, let me write down the efficiency of diesel cycle. It is 1 minus, this is the formula actually. I mean, you can't derive this within, you can derive this if you have time, maybe 10 to 15 minutes, but then you have to remember for this problem. So 1 minus Rk is the compression ratio, Y is the standard specific heat ratio, okay, by Rc is the cutoff ratio minus Y, okay, and Rc to the power of Y the specific heat by Y into Rc minus 1. Okay, so there are three different things here. Let me introduce, or let me first draw the diesel cycle, then it will be clear. PV diagram diesel cycle, you have a compression stroke, okay, followed by this is again to a lot top level, then followed by a constant pressure heating, and then the expansion stroke, and then the constant volume heat rejection. So this is volume V1, let me call, okay, and this is the clearance volume V2, and this is P, and this is V, okay, and this is another volume called V3, okay, where the fuel is cut off. So V3 by V2 is called as the cutoff ratio RC, and compression ratio, you know, compression ratio is the total volume in the cylinder by the minimum volume in the cylinder. Total volume is V1 by minimum volume is V2, so that is nothing but V2 is the clearance volume, basically is the smallest volume at TDC. V2 plus stroke volume is V1 by V2, so it is basically 1 plus stroke volume by clearance volume, which is nothing but V2. So all this we know, and specific heat ratio is basically your, it's a air standard cycle Cp by Cv, and that is directly given as 1.4. so with all this, so let's find all this and then we can substitute directly into the efficiency equation. Okay, so how do I get now? So first, in order to find out the compression ratio, I need the stroke volume. So first let's see the stroke volume. The stroke volume is basically, it's a cylinder, and then the length, stroke length will be given. So pi by 4 into d square is the area of cross section into the stroke length will give you the stroke volume. So pi by 4 d square is the stroke. So let's convert mm into centimeters. So 25 centimeter is the dia, and stroke length is 37.5 centimeters, so that everything is centimeter cube, volume is getting centimeter cube, and that is cc. So 18, so this if you multiply 18407.77 cc, centimeter cube, which is nothing but cc, okay, that is stroke volume. Now the clearance volume, the cutoff volume is 5%, the clearance volume is 1500 cc, that is nothing but V2 1500 cc, okay. So the only thing that is remaining is to calculate now Rk, which is 1 plus 8407.7 by 1500, okay, 18407 plus 1500 by 1500 plus 1, so that is 13.27. so 13.27 is the compression ratio, okay. Okay, now the thing is about, so once we got compression ratio, now the cutoff ratio. Now cutoff ratio, it is given, it's 5% of, basically 5% of the total, okay, the cutoff volume is given instead of directly the cutoff volume is given, but we need to now find out. So cutoff volume is basically, if you go back to the figure, this V3 minus V2, this is 5% of the total stroke, okay. So V3 minus V2 is 5% of the total stroke volume, which is 0.005 of the total stroke volume, which is V1 minus V2. So ultimately we need to find out V3 minus V3 by V2 from this. Yeah, V3 by V2 will be dividing by V2 minus 1 is 0.05 is V1 by V2 minus 1. So V1 by V2 is something which I know, it is the compression ratio. So 0.05, 13.27 minus 1, and you have to add that. So ultimately V3 by V2 is equal to 0.05, 12.27 plus 1. 12.27 into 0.005 plus 1 is the V3 by V2, which is nothing but our cutoff ratio, fuel cutoff ratio 1.6136. so that is cutoff ratio. So now once we got everything, the cutoff ratio, the compression ratio, it's time to substitute everything in this equation. So let me just put a mark here. 1 minus the compression ratio is 13.27, right? 13.27 into the specific heat 1.4, so minus 1 is 0.4. okay, now the cutoff is, we got as 1.61, so 1.6136, 1.4 whole to the power of 4 minus 1. Remember that minus 1 is not to the power of RC, it's in separate term, and 1.4 is Y, and RC is 1.6136 minus 1. So this is a calculator job, and once you calculate this, you get a value of 0.6052. so 0.6052, the answer is 60.52 percentage. So I think, I don't know whether they have asked in percentage or not. Okay, so maybe most of the time we have to specify in percentage, so it's 60.52 percentage. Okay, so that is the answer. Only thing about this is how to get what the things like compression ratio, the cutoff ratio will be cleared, but you have to remember the formula. That's the thing. Thank you.